So my presentation is about, well, the title is Could Virtual Threads Cast Away the Usage of Kotlin Coroutines? What Experience Can Tell Us? It sounds like a harsh title, but I think the conclusion will not be very harsh, but we'll see that in the end. So this is me in a nutshell. So I'm an engineer. I've been working for more than 10 years. I have different hobbies related to plants. That is my setting in my YouTube channel, which is called Just Protect. And this is me a long time ago when I started my YouTube journey. And this is my channel. But anyways, that's just me. We are here to have a look at Kotlin coroutines and virtual threads and how have we seen in practice at work and how they relate to each other. But first, I want to have a quick run through the history of threads in regards to Java and Kotlin. So in 1995, I think many of you know that this is where Java came into the scene of programming languages. We've got Java 1.0 and a concept called green threads. In 1998, Java 1.2 and the transition to native threads. In 2004, we had the ability to use concurrency utilities in Java. In 2011, the Kotlin language was announced. And in 2014, the project Loom was announced. And this was the project that came to be the starter of the Java virtual threads. In 2017, Kotlin introduced coroutines. And in 2019, Project Loom, in 2019, we were able to use Project Loom with early access builds. I started making projects related to this as well, and to check out how Java virtual threads work. And in 2022, we've got the preview. 2023, Java 21 and the official release of virtual threads. From this point onwards, we were able to start using virtual threads. And in 2024, the release was of Java 23, 17 September, with less pinning, but not significant. I will explain what pinning is also in this presentation. And in 2025, this year, in 18th of March, so not so long ago, the JEP 491 was introduced in Java 24, which allows for the end of the problem of pinning in synchronized processes. I don't know if who of you have heard about pinning? Right. So that problem is something we had also at work, and apparently it's solved now with Java 24. So I will have to suggest that at work as well, that we start using that. But before I continue, I want to highlight a few differences or a few benefits of using Java and a few benefits of using Kotlin in two different circumstances. So I've got here a very small diagram of a hypothetical example in the cloud where we need to get data from a user, comments and posts. And we need to fetch this data asynchronously. And we could do with Java virtual threads using structured concurrency that is now available there. The only thing is that this is highly verbose, which is something that we as developers complain a lot, or not, depending on how you work. But we see that we've got all of this code. We also need to specify scope join, scope throw if fail. And at some point, it becomes blocking as well, because we want to get all of the data and process it together. And so this can be simplified if, for example, we program that same Java virtual threads with Kotlin. So if we use this kind of code, then we don't have to use try with resources, and we don't need to handle the exceptions the way we did before. And so we can just use that use over there at the top, which is the same as using try with resources. So we see something more simplified, but it's still highly verbose. And it still has this problem with blocking. So what Kotlin coroutines can do for us in this case is another form of structured concurrency, which makes it a lot simpler to use structured concurrency. Simply using coroutines, giving it a context, which is this IO over here. So that's the coroutine context. And to launch this, we need to have a scope, a context, and then inside of it, we can launch asynchronous operations with deferred objects as well. and we can wait for them, and then we can process them. And the beauty of this is that that launch over there is not blocking, so none of this is actually blocking for our code. So we can use this just like this in our code, and as you can see, it's much less lines of code, which is the typical argument to use Kotlin to condense the code as much as possible and make it as readable as possible. But yeah, so this is essentially the summary of what I just said. But there are other cases where using Java virtual threads is much better than using Kotlin Coroutines. So for example, this is one example that is a parallel to what we already have at my workplace. So we need to send messages in packages of 50 in this case. Of course, these are analogous to what I have at work. It's not exactly what we use, because I can't talk in details about what I do at work. But the idea is that we can send 50 messages at a time in a fire and forget fashion. So if we use Kotlin Coroutines here, what happens, we can send it this way. We can send chunk messages, we can use this async here, and we can await all. This await all, essentially what it does, it picks up the map of all of these async calls, and then awaits for each one of them to continue before it sends another 50 message package. So the thing is that if we are launching coroutines inside a suspend function, anyone knows what a suspend function is? Yeah? So for those of you who don't know, a suspend function is, in basic terms, a function that can be used by a Kotlin coroutine. So it's a suspendable function where you can stop the execution of the function, for example, call something else, for example, a delay, and then the idea is that the thread doesn't get suspended. So in a nutshell, that's kind of what it is. But the thing is that if we want to use coroutines and launch them, then we do need that coroutine scope. Whereas if we use virtual threads, we don't need to use a coroutine scope. We simply can use it, and it makes the method more reusable. So we can reuse this better, and we don't need to use the coroutine scope all the time, which makes it simpler in this case to use. So there are two different cases here, one where we can use Kotlin coroutines for the benefit of our code, and the other one where we can use Java for the benefit of our code. And by the way, all of this code is being made in Kotlin, although I'm using Java virtual threads in Kotlin code, but I thought it would be easier to compare code that way rather than having one in Java and the other one in Kotlin. So what I wanted to highlight there is that there are benefits using Kotlin code and there are benefits using Java. But the other aspect, the actual important part of this presentation, is the tests that we've made at work to figure out what happens to our application, to the capacity of our services when we are making requests in different kinds of setups with Spring Boot. How many of you are using Spring, by the way? Yeah, and Ktor? A few, that's good, because you're probably not interested in the problems here, but out of curiosity, maybe. And Quarkus, anyone? A few, okay. See, the point of this presentation is because many of us use, fortunately or unfortunately, Spring, and then try to use Spring with Kotlin coroutines, which not always is a great thing. But the talk is about how to also understand how things work behind the scenes with Spring Boot and Kotlin coroutines and virtual threads. So the tests I have created here in my machines are different than the ones at work. In this case, I'm using this computer, which has 20 cores. So I'm quite loose in making tests in the way I want to do, but I also want the test to fail quickly, and that's why I've limited the container that I'm using for every single test to use 4 CPUs and 1 GB memory. Then another thing is that I am using a Postgres database. And in that Postgres database, I have one single table that is called product, and it has just a bunch of values in it. A sample product with a type room. Don't ask me why room, but I just somehow room ended up being there as a type of product. The idea is that we have data that we want to get from our REST services. Because we are going to test this with REST services in different kinds of settings. So the first setting is simply, first I wanted to run through the Python code to make these tests. So these tests are being made using Locust. Any of you uses Locust to make, good, yeah, sort of. Yeah, I find it a very useful tool, and it's you got alternatives like Gatlin or other JMeter, but I find this one to be quite easy to use. So essentially, what I've got is one endpoint that I'm using in the different applications, and I'm saying that I am returning the application /JSON types in the responses. It's not too relevant what's going on here. The general idea is that we are making requests and we are returning something, and then we are checking up until which point the application will fail and how much can it hold requests and what does it do with the overload of requests. So this is one example, a typical example of Spring MVC. We've got a controller. I don't think it's interesting for this particular presentation to show what goes on in service and repository. You can imagine that it works in the same way as usually does with the JPA way of accessing the database, and not much is different. I will put a link to the GitHub repository if you are interested in seeing the whole picture of the project. But essentially, what we are testing is this get items. So this is kind of the old way of doing of getting data from the database, but it's not really the old way because most of us actually do this all the time at work, I think, and so it's kind of the most convenient way of getting data from the database, but not really when we want to get a lot of requests from the database at the same time, or if we want to make a lot of requests at the same time to the database. So this presentation has been slightly improved. This is an old graphic of calls to that same service, but the only thing is that that service at the time didn't have any access to the database. It was just returning data in hard-coded way. So there was data being thrown back to the caller, and we can see that the application failed at about 1 minute. Was able to resist 1 minute with a ramp up of 1,000 users. Oh, it's not here actually. But, oh yeah, here, yeah. So 1,000 users per second up until 100,000 users. At some point, the application fails, which is the same what I have seen in this result over here. So we see that in this case, we are making requests. We ramp up 100 users, 1,000 users per second up until 100,000 users, and then at some point, the application starts failing. And here we see that the response times are really high, and therefore at some point it fails. So this tells something that we already expect from Spring MVC. So it's not capable of dealing with high loads of data. And what happens is, now the traditional Spring MVC, it is a great pattern. I'm not sure if we can say that still today, but it's just not that capable, not fast enough. Sometimes we say that, but it's really not capable. Can't really deal with too many requests at the same time. But it is an easy pattern to learn. It has a good 3-tier model view controller, domain model. Yeah, we can do all of that stuff that we can also do with WebFlux, data transfer objects, converters. The problem is that not many were aware of the inefficient aspect of it. So when we started to try to make more requests on these services, we would get the typical problem of too many requests, and the inefficiency, of course, only appear when raising the load. So Spring MVC wasn't seen as a good solution for high demanding services. But then we got WebFlux, which then implements the reactive way. And this is also something that we have in our at work. So we've got Spring WebFlux. We do use reactive, but we use Kotlin Coroutines at work. This is just here as an example, because I wanted to see the difference between using Flux and Mono and using flows and suspend in Kotlin, which are two different things. But if we check on the responses of this service, then we can see in the old model, where I was just returning hard-coded data, it would also fail at some point, right over here. So about 26 seconds, actually. But when I connected the service to the database, then what we see is that we don't get any failures. And the application seems to be trying to solve something here and something here where we don't get any responses. And it's trying to figure out where the requests are going to be handled, on which thread pool are they going to be sorted out with. And here, of course, there's a big point of where nothing really seems to be happening. But if I would let this go, this would continue resolving, and there would be no fails in the responses, which I find it interesting that just because it's a reactive application, then it can go on for so long without failing. So reactive programming 2017, I had a project. I have a project called C# Archiver. It's a weird project, but it implements all kinds of stuff related to reactive programming. It's an exploration project, and there I'm using things like Blockhound, which is a testing framework for reactive framework for WebFlux. It uses Flux and Mono. Flux we use for collections, Mono was used for instances. There's good support for R2DBC, good support for Spring. And the thing with Mono and Flux is the thing that everybody complains about, I think, which is the observability patterns and publishers, which seems to make the code very complicated. And it is true because, I don't know, you've worked with reactive code in Java, and I think you can agree that it's fairly complicated to work with it, right? So that is something that Kotlin Coroutines wants to solve. And I think personally that it solves really well. And I'm not advocating for Kotlin at this point. I'm just saying that it uses flows and it uses suspend function. And the rest of the code that we use can be done in, I think, the way many people enjoy using code, which is kind of an imperative way. Just simply putting functions and not having to worry about publish on or schedule on or whatever. It just uses this. But I wanted to see if Kotlin Coroutines would add any benefit to the performance of the application, because this is still a reactive application. So when I made the tests in the old way with the hard-coded responses, then what I saw is that the application wouldn't fail, and then I thought, well, maybe Kotlin Coroutines has something to do with it. Maybe there's a difference there if it's hard-coded, and maybe that's a fair conclusion to make. But when I connect it to the database, the pattern is roughly the same. So it starts holding out to all the different requests, and at some point it starts to figure out what to do with so many requests. It goes on, and then here it starts failing again, much in the same way as just using WebFlux directly without having coroutines on top of it. So what this tells me is that using Kotlin coroutines or not, performance-wise, is just the same thing. There isn't really a difference. It's just the readability that improves with Kotlin coroutines. Yeah? This flat line, it's not getting any responses at that point. So it cannot measure the amount of time that it took to perform a request. So it's trying to find to optimize the requests so that it can respond to it. It's part of the resilient way of dealing with these requests. So that's what this flat line represents. In general, it just represents that you're not getting any responses at that point for the services. But the fact that it recovers and that it continues, that's a positive thing for the way we handle these requests with these applications. Yeah. Huh? Yeah. Sorry? It is related to the database. So it's trying to it's not trying to connect to the database, it's trying to find a place to connect to the database and then a place to respond back to the caller. So that's why it's still. It's trying to find the best way to respond. Yeah? But we can talk after the talk, and then I can maybe give more insight into that afterwards. Yeah. So yeah. So why Kotlin Coroutines? Yeah, Kotlin Coroutines has something that can be beneficial to us, and that is the scope creation instead of a specific structured concurrency block. It allows structured concurrency. It has this concept of non-preemptive scheduling or cooperative multitasking, because Kotlin coroutines work in a cooperative way, which means that they voluntarily give control of the thread to other coroutines. And it has a better use of resources, concurrency. It has the addition of we can parallelize coroutines, and we can also select dispatchers, which means that we can choose what kind of threads we want to use, what kind of thread pools we want to use, if they are more related to CPUs or input-output or unconfined, or if we just want to use the main dispatcher. But this can also be a complicated thing using Kotlin coroutines. So it could be something that's not beneficial at all in using Kotlin coroutines. But in 2019, Spring allowed it to be, made changes to make it more compatible with Kotlin. So it meant that we could use Spring with Kotlin, but there are things that, as you can see there in the list that I put, a bit of a list of the good things and the bad things about it. But there are aspects of this that are that didn't work very well. For example, one of the things that that we have seen at work a lot of the times is that when we are using Kotlin and Spring, we are bumping into issues with null values that are being assigned to non-nullable variables, for example, which doesn't happen with Ktor or other frameworks. But with Spring, this kind of stuff happens. And all of this, the coroutine complexity was still considerable. Yeah, still try to use suspend with a returned list, or even with flows, in some cases also with flux. So for example, if we try to return a list in a suspend function using Spring and WebFlux and the project reactor for Kotlin coroutines, we are getting an object in the return type. We're not getting the actual value, we are getting something confusing. If we try to return an object in a non-suspending function, a normal function, then we are not using reactive in that way. So there are things that can be complicated using Kotlin coroutines. So basically what I want to say with this slide. This is a mental visualization, at least for me it works. So you've got all of these carrier threads, and you've got all these coroutines running. This is through time. And if we think about the way virtual threads work, this is kind of the same mental mapping, although they are fundamentally different, because Kotlin coroutines, when working with Spring on top of WebFlux, they are using event loops, and virtual threads, they were kind of on the thread basis. So this is just a way to visualize it, but it doesn't mean that it's exactly the way they work. It's just because we will see later on how can they work together, coroutines and virtual threads. So we come to the point of virtual threads in Spring. There are two aspects of this. We can activate virtual threads in Spring with this flag, and we can also select what kind of application we are using. Is it a reactive application or is it a blocking application? If in this case, servlet is the typical thing that we should choose according to the documentation if we want to use virtual threads. What happens when we do this is that all of our requests, our GET requests, our POST requests, all of those requests that we are using in the MVC model, they are now using virtual threads. So that means that it might not do any benefit when connecting to the database, but it will have benefits making different requests at the same time to our service. But we can also put there reactive. And if we put there reactive, that means that the GET requests, the POST requests, and all the different REST requests that we may make in our application will not use virtual threads. But odd things will happen, and that's something we also found out while making tests to the different kinds of settings for Spring Boot applications. So the first example is this one, virtual threads in Spring. So we're kind of doing exactly the same thing, and we're only relying on that flag to be using virtual threads. So every time we are calling this get items, we are calling this not via a normal thread, but via a virtual thread. So what you've got here is a virtual thread running. And I actually have that now in the code and printout to the console that says that what kind of thread you are using, and in this case, you are using a virtual thread. So that means that in the tests, the old test, with that application running with hard-coded responses, I got this. And I found it interesting because it's also not failing. Only here, it started getting longer response times. But it held up for a long time, for about 3 minutes. If we look at the way it works now, and we see that it's holding up for 3 minutes as well, but it seems that it's kind of steadier. It doesn't fail. I didn't let it go for a longer time, but I would expect, yeah, it starts failing here. But one thing that I realized is that, and this we saw also in our tests, is that the number of requests that are successful are kind of doubled here locally. At work they weren't double, but there were more requests being made in a shorter amount of time with Java virtual threads. And that's a benefit, I think. If we can make more requests before the application fails, I think that's something interesting to investigate and to use. So virtual threads, they started with Loom as fibers in 2017, and they were released in 2023 with the JDK 21, as we have seen before. Turns everything on its head for Spring. We will see that this is not entirely true. I need to correct this, but the problem is that the structured concurrency support is very verbose. Many frameworks surrounding Kotlin, like Project Arrow. Who here has heard about Project Arrow? Yeah. Project Arrow is an interesting project for Kotlin Coroutines, but it would be difficult to use it in a Java setting with virtual threads. Streams, channels, and flows are fully supported by coroutines, while it's still cumbersome to do that in Java. I found lots of places where, and I've tried it myself, you can do all this stuff in Java, coroutines in Java. It looks incredibly strange. I don't know if anyone else ever tried to do that. No, okay. But it's fairly complicated. Mobile application development is mostly based on Kotlin and Kotlin coroutines. So the use of Java has been going way down with Kotlin coroutines. So here is where we start talking about using virtual threads and Kotlin coroutines. So this is my mental mapping of virtual threads, and this is my mental mapping of virtual threads with Kotlin coroutines. So when we use the virtual thread dispatcher, what is happening is something like this. So we've got a carrier threads. The carrier threads are using virtual threads, and the virtual threads themselves are now distributing Kotlin coroutines. And again, this is just a simple representation of what is happening behind the scenes, and it helps me think about how this actually works and how potentially we can reap the benefits of using the combination of virtual threads and Kotlin coroutines. So, yeah. So this piece of code is part of the first example that I've made of this presentation, the first version of this presentation, and it's a bit strange, and I decided to leave it because it tells us how can we use the virtual thread dispatcher as a coroutine dispatcher, and how can we combine this using flows. So again, flows is kind of how we deal with collections in a reactive framework with Project Reactor. And then suspend, it's not, I don't have an example here with suspend with it in this part, but suspend we would be able to just return an object. But as you can see, we would be using this for virtual threads. And yeah, not construction, but does it stand? It didn't stand because I got a very strange graph here. As much as I tried to make tests against this endpoint, I realized that at this point, I wasn't able to do anything with my machine. Something was off, the service wasn't responding correctly, so everything was a bit off the rails. So I thought, okay, we cannot combine virtual threads and Kotlin coroutines, and I'm done. But then I decided to try just basically relying on the configuration with those flags, reactive application and activating the virtual threads, which of course we don't expect at any of these points to be having a virtual thread. So I was expecting to see exactly the same result as I was seeing before with the reactive application, whether it was with Kotlin coroutines or with just WebFlux without anything on top of it. But I got this. Yeah. This is what I got. And this I found interesting because this is also analogous to what we saw at work. When I activated both, I saw that this, the management of more requests, was better handled. And we also saw this at work, a slight improvement, not too much because this doesn't tell the whole story, of course, but we did saw a slight improvement. So what the hell? What happened here? I think that's a good topic to be investigated. The question I raised this question in this conference yesterday and the day before, and I'm still trying to find an answer to what is happening behind this, because it seems like something very beneficial, but this is something I want to investigate further. We didn't use this, we're not using this in production, so this is a decision that we decided not to do because it's not documented. It's just something that appears to work well with both of them at the same time. So my theory is that virtual threads are being used somewhere behind the scenes whenever Spring finds something that is not part of the reactive world, something blocking. So virtual threads combined with Kotlin coroutines. Different perspective on threads with potential benefits. I never use it in production. Investigated at work. Maybe it is not an improvement. We also saw that in other projects that we have, that the performance went down. So it's also a risk. And we can think of it as a strategic way of trying to improve the application performance, but it's not a guarantee. Let's just say that. Locally it did. Again, testing is needed and a lot of benchmarking is needed in order to make adequate decisions. Things that could be involved here are garbage collection issues and thread pinning, which I want to go quickly through that, what it is, because this is also something that we found at work to not only it seemed to slow down the application, but in some cases we actually had errors, and we could only fix it with Stack Overflow solutions. And that wasn't something that we wanted to do, but this luckily is solved in Java 24. But if you are wondering, and if you ever come across this, well, if you're using JDK 24, you can forget about it. But if you don't want to forget about it, it simply means that when okay, sorry about that. One virtual thread sticks to one platform thread. Mounting means that it can yield until completion. That means that the virtual thread can yield, and then that means that the other virtual thread can take control of the platform thread. Pinning means it cannot yield until completion. So if it is doing a sleep operation, or if it's doing something else, before it can complete and return the control of the thread, it won't. So the runtime will be stuck there, and that thread will be occupied until the end, which is exactly what I write here. So the problem was that non-reactive APIs like JPA or JDBC rely on several blocking paradigms, making it difficult to take the benefits from using Java virtual threads, because one part of it was thread pinning, which we ended up solving with using a combination of async and completable futures, and that was solved that way. Now, this table is part of another project I have called Good Story. And the reason I call it Good Story is because when Java virtual threads were being talked about when Kotlin Coroutines came about, I found it amusing to call it Good Story. And I decided to create a bunch of algorithms with different kinds of complexities and launch several virtual threads or Kotlin coroutines against them and find out how long they would take to solve these problems. What I found during this is that using a combination of Kotlin coroutines and what I call their Project Loom, but it's actually Java virtual threads, I saw that in many cases the execution time was faster. And it's weird because Java virtual threads isn't really something that is related to improvement of the CPU, but it is related with parallelism. And so the way the operations ran in parallel, I guess that was the reason, made that all of these different algorithms, which essentially they work with text, it made them work faster, which is something that is relatable to what we saw before using virtual threads and Kotlin coroutines on top of a reactive framework. So as a conclusion, virtual threads are very impactful because of their support by the Spring Framework. They are easy to use and build with. Maintaining code is easy, and it can be used in fire and forget scenarios, structured concurrency, both Java and Kotlin. Coroutines will still be used because of how well and elegantly they adapt to other paradigms like flows, channels, event streaming, servers and events. Can be used in both Java and Kotlin, but they are not prepared for Java and can get highly complicated that way. In any case, both can be used with similar purely equal performance markers, leading to choosing them on the basis of code style, patterns, and design. But there are buts here, and that's what I want to say here in the conclusion. So could virtual threads cast away the use of Kotlin coroutines? Yeah, because they are simple. We don't need complicated code, and we don't even need to think about dispatchers. And we don't even need to think about scopes. We don't even need to think about the coroutine context. But also no, because Kotlin coroutines still provide a more simplified way of using WebFlux with flows and suspend functions. I haven't seen yet an alternative in Java that could make it so simple as Kotlin coroutines do. So honestly, Kotlin is still a first-class citizen in the world, in my view, of code style and simplification for the JVM, and coroutines are a perfect match. And so the thing is, Kotlin coroutines are still a simplified alternative to Mono and Flux. So they in this case, they don't cast away, virtual threads don't cast away Kotlin coroutines. Although thread binning is solved, performance-wise, not much is observable. This is because when I made the tests with the JDK24, by the way, all of these tests were made using the JDK23 because Kotlin is not compatible yet with the JDK24. And I really wanted to test it with the JDK24. It was not possible, so what I did, I created an application with exactly the same code in Java, and I tested it with the JDK24, and I came up with the same results as using Java virtual threads with Spring Boot. Things that can contribute for the castaway thing. Virtual threads simplify the code a lot. So today, nowadays you only need to activate that flag to use it. The problem is that, I don't know if you've noticed when I was explaining the different graphs, the thing is, Java virtual threads don't really solve the problem yet when it comes to the JPA and JDBC. So they seem to solve that problem, and we saw it as well when a service is trying to communicate with another service or when we are trying to send messages. So that goes faster and it feels like it's working in a reactive way. But for the JPA and for JDBC, we didn't really saw improvements there, except for the fact that we get more successful responses quicker. Perhaps this could be solved using NoSQL databases or using something called JOOQ, something like that, but not what we usually use at work, the JPA to JDBC. So virtual threads combined with WebFlux may offer slight performance improvements. So if we use WebFlux without Kotlin Coroutines, and this proves to be something, then that is also an argument to cast away Kotlin Coroutines. So what's next? Java virtual threads have a definite future, but for Android at the moment, only up to the JDK 17 is supported. No support is available for Java virtual threads as a result. Kotlin Coroutines will stick around for Android for a long time, I think. In Java server-side, the use of Kotlin Coroutines may go down for simple applications and only where certain specific operations are needed. Will Kotlin Coroutines still likely be needed due to their simplicity and adaptability to reactive frameworks? For all operations related to structured concurrency, streams, and event handling, the use of Kotlin Coroutines may actually increase, as is the case with mobile applications in Android. And maybe coroutines can one day not be used anymore given the potential of Java virtual threads, even in the case of Android applications. But that isn't anything, in my view, for the near future. We have 7 minutes or 8 minutes. Are there any questions? Yeah? 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 Oh, because Locust tells you. Locust will immediately tell you that the CPU is overloaded and it will fail, which is part of the reason why I limited the resources in the container, because I want the application to start failing as soon as possible so that I can see the results. So I didn't use sorry. Yeah. So I didn't use the full capacity of the computer. If I would do that, I wouldn't see any difference. So that's why I limited the containers for that. Because I tried, the first test I started doing, I went head on, making tests and tests, and I couldn't take any conclusion. It was impossible to make any conclusion. So that's, yeah. Yeah. More questions? Yeah? Yeah. 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 I want to do that, but how much can I put in it in a presentation? That's kind of, yeah, but that's one thing that I want to do. Maybe a part two of this presentation to go more deeper into that, because there are three things. There's garbage collection. There's spinning, because as an inquisitive developer, I kind of don't trust everything I read at first. So the JDK24 says, okay, we don't have pinning problem anymore, but I want to see that in the logs and see if I can find that. And the other thing is, one of the things that could be contributing to the phenomenon that using Java virtual threads and reactive at the same time makes a difference could be that virtual threads are being used in the background somewhere. But that you can see in the logs as well. That's also part of a more in-depth investigation. So just checking the logs of the JVM in that sense, activating the right flags for it. I don't know them off the top of my head, but yeah. So yeah, yeah, yeah. Oh yeah, I skipped reading that. Yeah, yes, because there's if you go to a Kotlin conference, you kind of hear it all the time. There are different ways of implementing sort of stream-like things with Kotlin, and so you can make your own stream with Kotlin now, and it's very easy. And that's kind of why Kafka and RabbitMQ and other kinds of yeah, so those can, because the event streams, that's the word I was looking for, because event streaming can be implemented in Kotlin very easily and just a few lines of code, and that's kind of the reason why. But it's not to say, maybe I put it too harsh in the slides. It's not to say that that is valid for all kinds of cases. For more complicated cases, because Kafka has a lot of support for event streaming, and a lot of the things that Kafka does, I don't imagine doing that. It's two lines of code. But for many simple cases, you can do that with Kotlin. Yeah. I can't hear you very well. Yeah. Yeah. The Spring Boot. Yeah. Okay. For example, which flag? No, I mean, I can make other tests with. Yeah, let's talk about after the yeah after this section. Yeah. Any more? Yeah. Uh, what happens when we are waiting for the input operation to? So yeah, so the whole idea is that if we are waiting for an operation to complete, then the thread that the coroutine is occupying gets released for another coroutine to use. So that's the idea of how it works. That allows for more threads to become available in the system, in the JVM in the system. Yeah, yeah. Any more? Yeah. Yeah. Yeah, so the thing is, that would be part of the investigation for the second part of these slides. But that requires an investigation on how many threads are running, which threads are running, and if any of them is actually a virtual thread. Because if we are activating virtual threads, then I would expect that somewhere a virtual thread is being used or something else is being activated in Spring that has nothing to do with virtual threads, for example. But those are things that I don't know the answer to at this point. Yeah. Sure, if anyone has more questions. Oh yeah. So that's further in the slides. Oh, we're over 5 minutes. So these are the resources that I've used. Time's up. This is the where the source code is located. And I've got in the next slide the QR codes. Now, well, this is the about me, but these ones you can find here. So that's GitHub and that's my link tree. So there you can find all of the different social media and those things. And then this is the GitHub repo where the project is located. There are different examples there are different examples there, and you can use it yourself. I mean, it's very easy to use, and if you want to use it in your machine with different configurations, also with different Spring Boot configurations, you can try that. It's all ready for you to use if you want to investigate more. Not sure if... Thank you. Thank you.